Hello, this is section 2.4, average rate of change of a function. Now in section 2.1, recall that we learned that the net change in the value of the function y is equal to f of x between x is equal to a and x is equal to b is net change is equal to f of b minus f of a. So this is how we give the net change. Now then we also learned that the average rate of change of the function y is equal to x, f of x between x is equal to a and x is equal to b, where remember a has to be less than or equal to b. So it is given by the average rate of change, which we also denote by AROC, and it is the change in the y value divided by change in the x value. So f of b minus f of a over b minus a. But note here, what is this thing? Change in the y value means the rise, and change in an x value is the run. So it is rise over run, which is also the slope of a line, straight line. So now notice here, if we have a function and we take 2 points on the function, and where the first point here, this has the x coordinate a. So what will be the y coordinate of this point? So this will be a f of a. Coordinates will be a f of a, and the coordinates of the other point. So this point has coordinates a f of a, and this point has coordinates b f of b. So instead of now y2 minus y1 over x2 minus x1, which is the formula for the slope of the straight line, we are now writing it in a fancy notation. So the y2 is our f of b and y1 is f of a, and we divide by x2 minus x1, where x2 is b and x1 is a. So f of b minus f of a over b minus a. This is the average rate of change, remember, from 2.1. But now the same thing is also the slope of the secant line. What is a secant line? Secant line is a line which just passes through 2 points on a curve, at least 2 points. Okay. Now it may pass through other points, like for example, it goes over here, it crosses the curve here as well. But we are now looking at it between these 2 points. So we can say that the average rate of change is the slope of the secant line between x is equal to a and x is equal to b on the graph of f. So in other words, if there is a line that passes through a f of a and b f of b, then the slope of the tangent line, or AROC, is the same thing and is f of b minus f of a over b minus a. Also, the same quantity can be considered as the average velocity. So if f of t is the position function of an object moving in a straight line, then the average rate of change is the average velocity. In that case, the AROC becomes average velocity, and it has the same value. So now we've noticed that the AROC of a function, so we're talking about between a and b. Now sometimes what happens that instead of a and b, so we can have the same function or a different function. So if I'm looking at between these 2 points, let's say this has coordinate a, then the height will be f of a. But the second coordinate, instead of taking it, calling it b, we can call it a plus h. What do we mean by a plus h? Like it's a plus a very small number. So for example, if we are talking about a 2 and 2 plus h, so means, like for example, 2.2 or 2.1 or 2.01 or 2.001 or 2.3 or something like that. So in other words, let's say I tell you to find the AROC of a function of f of x between x is equal to 2 and a value goes to 2. So what can you do? You can pick and but it should be bigger than 2, okay, so that it's on the right of the 2. So now one student can say, okay, one value is 2, a is 2, b I am going to pick as 2.1 because 2.1 is very close to 1. Another student says a is 2, b is going to be 2.2. Another student might say b is equal to 2.01. So can you see the difference between the two is 0.01. This difference between these two is 0.2 and between the first two is 0.1. So these are very close to each other. So h is a very small number added in a. But now when we are drawing in our graph, we cannot be, I mean, if I draw it put it here, a plus h, and then you cannot understand what I am talking about, right? Because it's very, very close. So we can kind of think about that it's actually very close, but we are blowing it up to just show the graph. So we are zooming in. So this is what it looks. So what will be f of b minus f of a divided by b minus a will be the slope of the secant line, or the average rate of change of the function. And so now we have dealing with a and a plus h. So the formula will become f of a plus h minus f of a over h. Why? Because it is f of a plus h, f of b minus f of a over b minus a. So a plus h minus a. So a and a cancel out and we are left with h, and so we get this formula. Okay. So when you are doing the problems, you can directly start with this formula. You don't have to show this subtraction or in the bottom. You can directly start with this formula. Now this formula, when we call it number one, this is actually also called the difference quotient. Sometimes we look at it as difference quotient. In calculus 1, you will see that.